Hi, everybody. Welcome back to Dave's Math Channel. I'm your host, David Tare, and this is my continuing feature on the Math Lovers book. And I've been talking about relations for the last couple of videos. This is in section 5.4 of volume 1, which is on relations, which are a special type of just construction involving sets. Anyway, today I'm going to talk about domain and range, which are two very important concepts pertaining to relations. So let's begin. So last time I defined a relation. It's just a set of ordered pairs of two sets where the first element's a set of an element of your first set, and the second element of the ordered pair is an element of the second set. So what do we mean by domain and range? Well, domain is just the set of all values of x that lie in the relation. So remember what I said yesterday that you got these ordered pairs, xi, yi, if you like, and you just look at the set of all the values of xi, the values of little x pertaining to big X that are in your relation. It doesn't have to be all of x. And similarly, the range is the values of y that are in the relation. So in general, the domain is always a subset of the set capital X, and the range is always a subset of the set capital Y. Sometimes they're equal, sometimes they're not. So anyway, I think it's better just to look at some examples. So suppose our set X and Y are both equal to a set of natural numbers, which I'm calling n here, just a set of counting numbers if you like, 1, 2, 3, so on. And now this time I'm going R1 be the equality. So we say that x R1 y if and only if x equals y. So now we want to know the domain and range of R1. Well, I think it's pretty easy to see that both the domain and the range are all of n because you have 1 equals 1, 2 equals 2, 3 equals 3, so on. And so every element of capital X is represented by this relation R1 equality, and similarly every element of capital Y, which is also equal to n, is represented. So the domain and range of the equals for n is the whole set. And I believe that's true for every set, by the way. Whenever you have a relation from any set X to itself, equality relation, the domain and range are always the whole set. But anyway, let's do a second example. Again, let's let X and Y be the set of natural numbers, but now our relation R2, we say X is R related to Y via the relation R2, X R2Y, that's how we write it if and only if x squared equals y. We looked at this example yesterday. And so now once again we're asking for what the domain and the range are. So remember what the elements look like. Y is always x squared. So we start with 1, 1, 2, 4, 3, 9, 4, 16, so on. Well, I think you can see that every value of x is represented. So the domain is just all of n again. But this time, not every value of y is represented because it's only the squares. So the range of this relation R2 is just a set of squares of natural numbers. It's not all the natural numbers, it's only the squares. Um, anyway, that's just two kind of simple examples. I'm going to do a third one. Well, actually, I'm going to do, I guess, yeah, I forgot to switch this slide. I've been having problems with this anyway. But okay, now for the third one, I'm going to do the same thing as the second example, except this time I'm going to look at the real numbers instead of the natural numbers. So this time our domain and our range are both a set of real numbers, and I think you guys all know the real numbers, the number line, just a set of all numbers from minus infinity to infinity. So, and again, we say that x are 3y if and only if x squared equals y. Um, so once again, you can start with any value of x you want. It could be positive or negative because you can square any real number. But one thing I think you know about the squares of real numbers is that they can't be negative. They're always they're always non-negative. They can be any non-negative number, but they can never be negative because only imaginary numbers can have negative squares. So in this case, the range is just a set of non-negative numbers, non-negative real numbers. So anyway, those are three simple examples of uh, domain and range of different relations, and you can do for any relation you want. So that completes my video for today on domain and range. These are going to turn out to be important concepts when we talk about functions. Remember, I said relations are a special type of function is a special type of relation. Functions, I think, are in general a lot more useful in relations, but it's good to know both. Anyway, that completes my video for today. So thank you for watching. Long live math, and I'll see you guys next time. Bye.